Hello everyone. Now we continue from the last lessons. Today we're gonna learn how to find the value of limits. Okay, so just say limits. Gonna have the types of limits. How many types of limit? So we have 3 types of limit. So first one is a two-sided limits. Second one is a left-hand limits, and third one is a right-hand limits. Okay, so then today we're gonna study for the two-sided limits first, but next one, so we can find get the idea of how to find the limits. So this one, right? For every case, we have to find out existence of limit and the non-existent. Like this one, right? Existence limit. Another one is non-existent limits. Okay, so we're gonna learn this one first. This one, first one, exist the how to find the limit, the value of limit. So first of all, from this one you can first one replace f of x, okay, and then replace x whatever limit applies to. And the second, if you can like this one, for example, like a last example, come back to hit this one. F of x equal to 0.1 x power 4 minus 0.8 x power 3 plus 1.6 x power 2 plus 2x minus 8 over x minus 4. This is a previous example, okay, if you remember. So previous example limit is exists, right? This is equal to 2, if you remember here. And when you plot graph, you're gonna have the open dot here, right? Remember that one? Okay. So the first step, you want to find limit is exist or non-existent or non-exist or non-existent limit. Then first step, you just replace, because the question, this one example, right? The given f of x equal to this, and I want to find limit f of x when x equal to 4. Then you just replace x equal to 4 in this function. Okay, so when you replace x equal to 4, right? So the replace everywhere I have x here equal to 0.4. I mean x equal to 4. This one becomes 0.8 times 4 power 3 and plus 1.6 times x power 4 plus 2 times 4 negative x. So when the top here numerator, you will get some number, right? So I leave how what we can use calculator over, and this one when you replace equal to 4, they're gonna be 0. So in the general, we're gonna answer this one like in previous years when you learn the find the value of function. This one you're gonna answer undivided, right? You can answer undivided. So if this is the first step here, when you replace f of x, no matter what x equal to, right here, when limit x equal to 4, you replace x equal to 4 right away. So they come out become undefined, or if they come out like a 0 over 0 or infinity over infinity. This one, in this case, 0 over 0, infinity over 0, or infinity over infinities, we did not call this undecided. Most of the time we answer as undecided. Okay, because that means they can have some value or answer. So we write it down as an undecided first. Instead gonna say undecided. Okay. Instead gonna say undefined, sorry. Okay, like this case you can answer undefined, right? But this one we write it down as an undecided. Now, if first step we find out in this case, right, become undefined or undecided, then we go the second step by simplify it. simplify the function to the lowest term. Okay, so now we come back to this example f of x here. This one, right? Still go on for the example. So this one is this function is a rational function, correct? So we see, can we make a lowest term, simplify to lowest term? It couldn't do, right? So this already simple term already. So if you find out this one, the second step, once you couldn't continue, then we go the next step, third one, use table. Use table, that means this one, right? This one. We just do the last example, this one. So you use a table when x approaches 4 from the left and x approaches 4 from the right, from the left and then from the right. Okay, so then we can see when you, because approach to 4, if from the left you get the replace x with the approach closer and closer to 4, like a 3.999, like in this case, the y value come out become 1.9984 from the left, and from the right, when you substitute x, when x approach just as much as they can to the 4 from the right. For example, like a 4.001, the y value come out to be 2.0016. So from this one, you can see you can round it up, right? Become 2, and this one also approximate, right? When you round it up, gonna be about 2 also. So that's why this question, when you find out the limit f of x when x approach to, when x approach to 4 will equal to 2. Okay, that's a previous example. So when you want to find the limit, is x to find the limit axis or non-axis, on axis or non-axis by these 3 steps. Okay, so this is an example from last one. Now today and last one, when we use a table that we lead from the left and from the right. Okay, this is the x approaches to the value of x. Don't forget the formula limit f of x, right? The informal definition of limit. Remember last period, limit f of x when x equal to c equal to L. Okay, now c in this case is what? 4. This c, that means equal to 4 from the question. L, that means the value of y, which is equal to 2 in this case. Okay, f of x means the whole thing here, f of x, the functions. Okay, then don't forget this one. This is the, how to say, the formula of writing for the limits. Okay, now we gonna go for next example for the axis of limits. Okay, so we see the next example. Now next example is this one. So I have to erase the thing first, okay? Erase the period one. You see now this formula last lesson we learned, right? This one. Okay. So now come back to the next example. I will use this one. This is the right blue color here. This one, if f of x equal to sine x over x, and then find limit f of x when x equal to 0. That's the one I write down here. That's an example. So again, we use a 3-step, right? How to find the value of limit of functions. First one is what? replace f of x in the formula, in the functions. So the first step, because x approach to 0, correct? So the first step we do is, that means when f of x equal to, I may become the limit right away. You can write down, say if limit f of x when x approach to 0. So then this one you can write out, once you replace x, right? So limit writing gone. So this one, if this one becomes psi, this one psi x over x. So when you write down this one, replace becomes psi. Limit f of x. Okay, I think should replace right away. So when you replace x with a 0 and over 0, so this one come out become, because psi 0 is a 0, right? The first quadrant of order is still 0, so then 0. So in this case, the undecided, correct? Then this first step couldn't do. Then go to second one for simplify it. Also, this one couldn't simplify either because it's a low weight term already. So we go to the next step by using the table. Okay, the table you can see here, back to here. I write down here already. So use the idea from limit x approach to 0 from the left, right? From this one. So you may start to maybe say negative 0.4 and replace x in there, become psi negative 0.4 over negative 0.4, and then you can get the value y is this one, becomes 0.97545 something. Okay, and you approach closer and closer to x equal to 0. Then the most close right now can be even closer than this, but just say show right now give you only negative 0.001. So you replace this one in the value of x also. It becomes psi negative 0. Okay, maybe I try do this one. Okay. Because when you replace this one, psi negative 0.001, right? Over negative 0.001. So this one equal to what? Psi, like a formula of psi negative theta, right? Right, the formula. So become minus, right? Minus and minus become plus. So you have psi 0.001. I mean, become plus, right? I mean, if you this one become minus psi 0.001 over negative 0.001. So this side, just say this approximate 0.01 is like a psi 0. Okay, so psi 0 is what? And this negative become plus. So this one, when you replace in, you're gonna get y equal to this one, 0.9999. Okay, from the left. So that's why come out positive. And when you replace 0.01 from the right hand side here, you will get the same answer here because both of them become plus. So 0.99999. So again, similar to previous example, when 0.999, you can round it up, approximate is what? 1. And this size also 1. Okay. So this side is also 1. So in this case, you can see the limit of this function, right? Limit of the function when x approach to 0 will equal to 1. That's the answer. So this example is really important for, it's really important in the calculus. So you can use this this idea to be your reference when you do calculation. Say limit of sine of x over x will equal to 1. Okay, just keep in mind this one. Okay. So then this is, then we know this one, limit function f of x or limit sine x over x when x approach to 0 is 1. Okay, 1 is a value of y actually. We need the value of y. Okay, now we go next example. 2 more example, I think, and that's all. And okay, I have to go here first. Next one. Okay, so then this one I have to go to the next example. Then I will want to erase this one out. Okay, erase the period. Maybe I erase all. Okay, so now we come to this example. This one, okay. I use the purple color. Okay, find the limit f of x when x equals to 2. Okay, f is the function given by the following. Now, f of x equal to 0 if x is an integer. F of x equal to 1 if x is a is not an integer. So this one have 2 functions, correct? Have 2 functions. So when we plot graph, I think it's a help. When say, what is integers numbers? Integers number, everyone still remember? We have 3 kinds, right? 0 and positive integers and negative integers. Okay, so positive integers is what? 1, 2, 3. If you draw on the number line, if you draw a number line here, right? Maybe I draw it here. So integers have 3 kinds: 0, positive integers 1, 2, 3, right? And so on to positive infinity. And left hand side is a negative integers like 1, 2, negative 3, negative 1, negative 2, negative 3, like this, to the negative infinity. Okay, so now we're gonna plot the first one first. First graph when f x equal to 0 if x is an integer. So this is the first function. So then you say, if you say x0, right? x0 here, because x0 is integer, so y gonna be 1. I mean, y gonna be 0, this one, for the first one. So gonna be this dot, right? Maybe I use another color, pink color better. Okay, so if x0, y0, if x1, now we plot the first one, okay? If x is 1, y still 0, and x2, y still 0. If x3 is 0, and dot dot. So to the left hand side, negative integer, if x negative 1, so y still 0, and also still at. So the first graph for the first function when x of x equal to 0 if x integer is only the dot here. the pink dots. Okay, so now we see comport the I use this color. Okay, plot the second function here. If f of x equal to 1, function f of x equal to 1 if x is not an integer. So you can see how we plot for the second one. So like this one can be 0, 0.01, 0.02, and so on, right? Between here, that is not integer. So can be fraction, third, decimal points, something. So when you replace any number between 0 and 1, you will get what? Y equal to 1 here. Okay, so you're gonna have 1 here, right? So because it's a real number, so for now you're gonna have like a one line between 0 and 1. But if x equal to 0, or the second graph, okay, I mean here, this second function, if x equal to 0, so this one can be, right? So you just like open dot. If and then also if x equal to 1, this one gonna be open dot. Then now we pause the second function, okay, don't forget, and so on. So this graph, when you plot, this gonna be the second function. Okay, for this one, when f of x equal to 1, function f of x equal to 1 if x is not an integer. Okay, so from this one, the question want us to find the limit of function, this one, when x approach to 2. Okay, so then you see where the 2 is here, right? So from the left, in this case, is you have to read the value of x from the left hand and from approach to 2 from the left and approach to 2 from the right. So from this one, from the left and from the right hand side here. So because if you read limit, right, read the limit f of x, read the limit f of x when x approach to 2 from the left and from the right. So if I know this one approach to this one, right, that means y equal to 1. So that's the answer. But if asking you this, if function f of x when x equal to 2, then what we're gonna answer? When x equal to 2, like now this like a previous year you learned. So you replace this one, right? X equal to 2 is x equal to 2 is an integer, right? So is your answer equal to 0, correct? This one function, okay, but this one limit. So not the same. So then when we leave function, when x function of x when x equal to 2, the answer is a 0 according this one. But when we leave the limit, we leave from the left and from the right, approach to 2. The answer, the value of limit equal to 1. So in this case, they are not, doesn't equal, right? It's not equal. So then this one is a discontinuous function. Because you see they have broken open dot between the graph. Okay, so now we go this in this question they have it different, right? Because they have two functions. So now we go the next example. Maybe and then you practice more question and then you will get it. You will understand later, more understanding. Okay, then we go next one. Go to the next example. Okay, then I have to delete all the thing again. I will delete the old one here. Oh, okay, that's okay. We don't need that one anymore. see this example, okay? Find the, if f of x equal to sine pi x square minus cosine pi x, find the function of f of x when x equal to 0.5 and limit f of x when x equal to 0.5. In this case, you see this one is a polynomial, right? Function, but in the trigonometry concept, okay? When this one is a polynomial, it's a different from this example, correct? This one is a rational function. So if when we do this one, first one, we can find f of x when x equal to 0 right away. So how to do is, you just replace 0.5 here. Replace x in there, become sine pi. 0.5 equal to what? 1 over 2, right? So we can write pi, become pi times 1 over 2, become pi over 2, right? So minus cosine pi, replace x as a 1 over 2, become pi over 2. So now this one becomes sine, this is 90 degree, right? Sine 90 degree is what? 1. So become 1 power 2 minus cosine 90 degree is 0, so equal to 1. So that means when function, when f of x when equal to 0.5 equal to 1, this one is what? So equal to 1, that's the answer, okay? Now we're gonna find limit f of x. Limit f of x when x approach to 0.5. Approach to 0.5. So in this case, you can use the table, right? Because this already simple term. This form is already simple function already, simple term already. So couldn't simplify either. So then we use the table, correct? From this one, use a table. So you can see this one there, calculate. So if x approach to 0.5 from the left. So if we say x equal to 0.49, this one, the value of y can get become 0.99, this one. If this is from the left, okay? And from the right, if x approach from the right, you replace x with 0.51. Okay, you're gonna get the value of y, so 1.01 here. So you can see this one 0.99 and 1.01. Both sides, this one, when you round it up, become 1, right? And this side become 1 also, correct? So we can say the limit of this function, okay? Or we can write down, when you write down. Limit of this function gonna be 1 by using the table, also 1, okay? So in this case, if the function is like a polynomial, not a polynomial function, right? Then we can use another way. Instead, gonna use a table pattern here. We can use the properties of limit. Remember, last class we learned. So if in this case we use the limit, the properties of limit, we can write down that in this way. Say from I rewrite here, okay? F of x equal to sine pi x squared minus cosine pi x. So I want you to use the properties of limit. So I take limit both sides. So I write down limit f of x equal to limit sine square pi x, sine pi x squared minus cosine pi x. So then use the property limit. How to do? You have to write this one also, x approach to 0.5. This one is really important. You have to write every time, okay? X approach 0.5. Okay. So now expand it, right? Become limit sine pi x squared when x equal to 0.5 minus limit cosine pi x when x equals to 0.5. After that, you just replace right away. When you use property of limit writing, right? You just replace or substitute x with 0.5. When you substitute or replace the value of x 0.5 in here in this step, limit gone. Okay, you don't need to write down. So you just write down become sine and replace this one 0.5 or 1 or 2. Okay, so minus no limit, sorry, become cosine pi over 2 right away because 0.5 is equal to 1 over 2, right? So then you get the answer right away here, equal to 1. Okay, so then see this, you can, this is a way how to find and show the work. Okay, that's I take a time here because that's the way how to write it down, show the work correctly when you want to find the value of limits. And right now this exists, right? Because both of them exist. And at the same time, you can see this, when you find find the limit of function when x equal to 0.5, the answer is a 1 here, right? The same thing. And this one equal to function f of x also. This also 1. So this is equal, right? So if they're equal, you can say this function is continuous. Is continuous. Is a continuous. So then this one, the limit of continuity, we're gonna learn more in detail later part, okay? But now you just get the idea. If when you find out function f of x, the value of function f of x equal to limit of function x equal to whatever here, the definition here equal to c, right? So if they're equal, then we call this a continuous function. And then you can see the graph on the left hand side here. The graph, you see they keep moving because this one is a little bit hard to if you plot by manual. So this one they use the TI, Texas Instrument calculator, to plot the graph. So you see the graph keep continue, right? No open dot, no empty dot. Okay, so the line keep continue. Okay, no space. Just say okay. So then we say it's a continuous. Okay, but then you remember, come back to this, the first example here, come back here again, this one. Okay, this one is this continuous function, because when you plot graph, remember this one plot graph somehow like this, right? They have one open dot here. So this one is this continuous. Okay, because they have one open dot here, but this one continue. Okay, the continuity. Okay, this idea briefly, and this one will relate it to the later part, so try to understand this one. And I think that's all for the example for existence of limit. And we're gonna go for non-existent, the second one here, non-existence limit. Okay, so I stop this one right here and we go see you next class, okay, for the non-existent limits. Okay, bye-bye. Thank you.